f of x equals 4 over 4 minus x squared plus 1 for x is greater than or equal to minus 10 and it's less than or equal to 10. You're given some x's, so you're given a minimum x value of minus 10, maximum x value of 10, as is the same as this domain given here. You're also given a minimum value of y of minus 5 and a maximum value of y of 8. So there's some blank axes with very, very handy markings on them. What we have to do is sketch f of x on the axes provided, find the zeros of f of x, find the y-intercept of f of x, give the equations of any asymptotes of f of x, give the range of values of k for which f of x equals k has no solutions, one solution, two solutions. So I'm not going to explain exactly what all of these mean right now. Obviously, all will be revealed during the question. So let's begin with part A, sketch f of x on the axes provided. So we need to go to our calculator and we need to go to the graph feature and we need to type in this function. Now, depending on your particular model of Casio, it's all about a fraction button. So mine, it doesn't have a proper fraction button for in the graphing features. So I'm just going to use a divide sign. So I'm going to use a bracket. I'm going to write 4. Try that again. I'm going to write 4 over, and I'm use a bracket, 4 minus x squared, 4 minus x squared, close the bracket, plus 1. Just like that, should be okay. I'm going to press draw, and I'm going to have to alter the windows. So the x min needs to be minus 10, x max 10, so go to Shift V window, x min minus 10, max 10, skip scale, skip dot, y min minus 5, y max 8, minus 5, y max 8. So then we are looking at the exact window. So the calculator screen, this is now exactly the same as this screen around here. So now we can transfer. So if you look at this, you've got 3 distinctive parts. So you've got this that kind of looks a bit like a parabola, a curve coming down, looks quite symmetrical about the y-axis. And then you've got these 2 sort of other curves coming off, and they look quite symmetrical to each other. If you take the y-axis as a line of symmetry, they come just above the x-axis both ways. And it looks like, you see this line here seems to kind of line up with that, and you can say the same. So this line at the bottom seems to line up with that. So that's how I'm going to draw it. So I'm going to start with the curve. So something like, it's not brilliant. It should be a bit more symmetrical. I'm going to leave it because it's still, I think, probably enough for the marks. And then I want this to kind of line up. So I'm going to start down here. And I'm going to do something like that, and I'm going to line this with this, something like that. And those look reasonably symmetrical. The biggest problem is here. But never mind, I still think I'd get all the marks for that. Right, so sketch it on the axis provided. Find the zeros of f of x. Now for zeros, there's many ways to ask the same question. Zeros are basically what value of x makes f of x 0. So when is y 0? So that happens here, and it happens here. So really you're looking for x-intercepts. So if I look for zeros, that's the same as x-intercepts. They're often sometimes called roots. Or it could be find the solutions to f of x equals 0. So this is just different ways of asking the same question. You do need to be aware of this because you could be asked this in various different ways. So anyway, I can find these using gsolve. So Shift gsolve, and you can see on the Casio they are called roots. So I need to go to F1 for a root, and I can see this point here is that x equals minus 2.828427 and y equals 0. So I just need to give the 0. So I just need the x value. And remember, 3 significant figures unless prompted to do otherwise. So minus 2.83 So minus 2.83, and the other one, remember I can navigate between these two, so I need to go over here. I can just press this right arrow, and it's looking like these definitely were symmetrical, because now it is 2.83. It's just the same number but positive, 2.83. So that's the zeros found. Part C, find the y-intercept. So the y-intercept is this bit here. And again, your calculator has a function for that, so Shift G solve. And you can see y-intercept is the fourth one along, so press F4. And that is at 0, 2. So if you want the actual y-intercept, I'm just going to put 2. So that's technically the answer to the y-intercept should be one number. Just be aware you could be asked give the coordinates of the y-intercept, and in that case you'd have to write 0, 2 in brackets with a comma as a coordinate pair. Give the equations of any asymptotes of f of x. So we're getting into the tough stuff now. So asymptotes, I'll talk about vertical ones first. So a vertical asymptote is kind of a line that the function doesn't quite, it's where the function is undefined, and the line will get really, really close to this imaginary asymptote line, but it will never actually cross it. It will never touch it. So it will approach it and then it will kind of jump across the other side. So if you remember when I was saying this kind of lines up with that, well, it does. If I just draw this imaginary asymptote in here, that is where, if you look here, this leg, if I kind of increase x, this line's going to get closer and closer to this asymptote, but it's never going to actually get there. And if I was the other side going this way, the same thing would be happening. If I'm going here, it's getting closer and closer and closer to that value, right? So we just want to know, well, what is that value? And the best way I think to do this is to use the trace function and just kind of follow the function along and see where you're going to. So if I press Shift and F1 for trace, and then I can just use the arrow, so I'm just going to go up there. So I'm going to move along here. If you look, doing the same thing on the calculator, we're moving along. And you can see x is minus 1.74, y is 5.2. So I'm up here. If I press it again, you can't actually see the arrow, but x is minus 1.904 and y is 11. So it's just off the screen there. And if I press it again, I've gone, y is now negative. You just see, so y has gone from positive 11.7 to negative 14, and x is now minus 2. Before, x was minus 1.9. So it looks like it's kind of hopped across 2. And if I just, you can see I'm now definitely to the left of that, and it kind of hops. So I suspect that this line is at 2. And if you have that suspicion, what you can do, you can just type in, so I keep saying 2, well, I mean minus 2. So if I just type in x as minus 2, it's telling me when x is minus 2, well, there is an error for y. So it's telling me the function's undefined when x is minus 2. And vertical asymptotes are where the function is undefined. So x equals minus 2 is the equation of this vertical asymptote. So it's a line that the function gets really, really close to, but it never actually touches, and then it starts again from the other side, having jumped across it. So it's a discontinuity in the function. So the first one is x equals minus 2. Now I think I've got another one very similar here, and hopefully you already probably know that just thinking about this symmetrical, this is all very symmetrical, it's probably going to be, it's going to be 2. But we'll follow the function in the same way. So if we start to kind of go look for this line either side, so I'm coming up towards it, you can see the x value 1.58, 1.74, y is positive 5, 1.904, y is 11.75. Now on the other side, past the 2, y is negative, so it jumped down here. So it went from up here off the screen to down here in one jump, and it happened either side of 2. So then if I put the value of 2 in, it happens again. When x is 2, y is an error. So x equals 2 is the other vertical asymptote. X equals 2. Now there is one more asymptote, a horizontal asymptote. Now horizontal asymptotes are different to vertical ones. Horizontal asymptotes the function sometimes approaches those, but for very, very large values of x, or for very, very large negative values of x, or for both in this case. So basically, if I was to sort of follow this along off the screen and follow it along that way, it might approach what's called a limiting value. So it might get closer and closer and closer to a value that it will never pass, but it will get extremely close to it. So I'm going to follow this function again, and I'm now interested in the y values because I'm looking for a horizontal asymptote. So I can see y 0.74, 0.76, and so on 0.8. And I'm actually going to go off the screen for this. So I'm up to 0.91, 0.92, and I'm going to keep going. So do be aware when you do that. So I've just now moved off screen. I will have altered my view window, so I'm going to put that back later. So 0.97, 0.98, and so on. And you can see as x is increasing still at the same rate, the y values are now increasing really, really slowly. This line is nearly flat, 0.99999, and so on. And it looks like I'm getting really, really close to 1. Really, really close. So you can see I'm at 99. If I keep going, I'm at 996, I'm going to go 997. I reckon that y equals 1 is probably going to be the horizontal asymptote, which would kind of look like that. But what I can do, I can draw that on the calculator. So now I'm going to just go back to where I was. So I'm going to go, if you ever find you've messed up with the view, if you've zoomed it or you've moved it, I'm going to go view window, I'm just going to reset it. So you can see that's way out now. The y bit hasn't changed because I didn't go mess about with the y, but the x values have changed. So minus 10 and 10 it was. 10, execute, draw. Oops. And then I'm back to where I thought I should be. So I'm now going to draw y equals 1. So if I go back up there and just draw 1, you don't need to draw this on your graph, but it looks right, doesn't it? You can see this curve kind of looks like it's approaching it. You can zoom in if you like, but it is correct. I'll leave that up to you to see if you want to do it. But this other line is y equals 1, which is the horizontal asymptote. So when x gets very, very big, and in this case very, very big but negative as well. So think really big values of x. So when x is 100, when x is 1,000, when x is 100,000, this y value is going to be really, really close to 1, but just under. It'll be 0.9999 and so on. So y equals 1. So there's 3 marks for 3 asymptotes. Part E is quite hard. So find the range of values of k for which f of x equals k has no solutions, 1 solution, and 2 solutions. So really we need to think, well, what would a graph of f of x equals k, or y equals k, say y equals k, what would that actually look like? So k is just a number, so you're looking for numbers of k that make certain things happen. So imagine, say, y equaled 3. Hopefully you know what that looks like. So anywhere along that line, the y value is 3, so it might pass through, say, 0, 3, 1, 3, 2, 3, and so on. Minus 1, 3, minus 2, 3. It is a horizontal line just like that. Y equals 3. Say I had a line down here, well, if that's 3, that might be, say, minus 4. Y equals minus 4, maybe. The point is, y equals number is a horizontal line which has the y-intercept of that number, so it just goes through all the way. So I need to consider on this thing here, what horizontal lines could you draw such that when they have when they equal this function that's already there, they have no solutions, 1 solution, 2 solutions. So hopefully you can remember the last video we did when we were seeing intersections. We were looking at where does f of x equal g of x. So if you could think of, say, g of x equals k, and we're solving f of x equals g of x, when it says number of solutions, it's the number of times they cross. So if we know that y equals k is a horizontal line, so just think of horizontal, imagine the pen being, it's a bit fat, but the pen can be your y equals k line. So if I put it there, a line across like this, you can see it's going to cross twice. It's going to cross here and it's going to cross here, and so on if I put it here. Most of this plays, it's going to intersect with this f of x equals that. It's going to cross it twice, but it's not going to cross it twice everywhere, because there's this little region in here, so in between the bottom of this curve and the start of this new curve underneath the asymptote. And that's the region where you're going to get your 0 and your 1 solutions. So say I can just lay it there. It's a bit fat, the pen, but if I could sort of lay it in between there, I could draw a horizontal line that wouldn't touch this other function that was already there at all. So that's how I get no solution. So what I really need to know, I know about this y equals 1. What I don't know, well, I probably do know, but we need to be sure. I don't necessarily know where the lowest point of this curve is, so hopefully it's going to be higher than 1. So I suspect it's the y-intercept, because everything looks very symmetrical, so I strongly suspect it's at 0, 2, but we should confirm that. So we're looking for a local minimum of that curve. So what we're going to do, I'm actually just going to delete this y equals 1 because it can get confusing. So delete that formula, and I'm looking for Shift G solve and the minimum. So yeah, I can see that was indeed the minimum. So when x equals 0, y equals 2. So this has the coordinates of 0, 2, that point there. So y equals 2 is this line across here. So basically, if y equal 2 was a line, so y equals k, meaning k equals 2, then it's going to have one solution. So k would have to be 2. Imagine the line y equals 2 will just touch the bottom of this curve once, right? If I draw y equals 2, you shouldn't draw all these lines on yours because you've got to be graded for part A, but I'm going to do it. So that's y equals 2, just like that. So I'm going to skip straight to one solution, so k would equal 2 for one solution, because remember we're thinking about the line y equals k. So now for no solutions, it's got to be in this kind of no man's land in between the bottom of this curve and the beginning of the next bit. So they start the other side of that asymptote. So if I drew the line y equals 1, the asymptote doesn't touch anything, so 1's okay. And then anything below 2, if y equals 2 we know has one solution, but if it's less than 2 and bigger than 1, or it could be 1, then that's going to have no solutions, because that's kind of a line in between these two lines. It's quite small to see, but hopefully you get what's going on. So k needs to be smaller than 2, but it could be 1, because if we drew the line y equals 1, that would be that horizontal asymptote that doesn't touch any lines at all, because it's a horizontal asymptote. Right, so for 2 solutions, but that's everywhere else, so it's anything bigger than 2, it's going to cross twice, 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 and it's anything smaller than 1, twice, twice, twice. So k could be bigger than 2, or k could be smaller than 1. And that is everything for that question.